Welcome, everyone. Thanks for attending today. I'm Dave Alexander, Marketing Manager for Sony Healthcare and our medical integration products. As the worldwide leader in imaging technology for minimally invasive surgery and experts in 3D and 4K video technology, Sony brings a wealth of value to the industry, equipping clinicians with tools that elevate the level of care they provide on a daily basis. Today, our experts will provide an overview of the technology behind Sony 4K 3D displays, video recorders, both of which are used extensively in robotic surgery and other 3D surgical imaging systems today, delivering enhanced visualization for surgical teams around the globe. We'll also present the Sony NUCLeUS platform and the many benefits it offers when integrated in robotic surgical suites and other areas of the facility, and specifically how the highest quality 3D imaging can be maintained and utilized in training and education. Our presenters for today will include David Kurowski. Based in the Chicagoland area, Dave is an account manager with Sony and has been in healthcare, specifically video for use in the OR, for over 30 years. Dave serves many key accounts with 3D and 4K video for robotics, ophthalmology, as well as neurology and other applications. After Dave, we will hear from Paul Nunez. Paul is a systems engineer here at Sony and the Healthcare Group, based in Arizona. And Paul has been in audio video engineering for over 30 years. Paul has worked in healthcare video, broadcasting, as well as many other aspects of video integration in and out of the clinical space. Very important, there will be time for Q&A at the end of today's session, which we of course value highly. Please do use the on-screen utility to submit your questions at any point during the presentation. Also, some of our key brochures and cut sheets are available for you to download here during the session, also in the interface. These gentlemen are indeed subject matter experts, so please do capture any questions you may have, no matter how deep in the utility. If we run out of time, you will still receive an offline response to make certain we get you the information. With that, again, our thanks for your time today. Happy holidays, everyone, and we'll toss it over to David Kurowski. Dave?
Season's greetings and good afternoon. Thank you for joining us today. My name is David Kurowski, and I'm one of Sony's business development managers within Sony's healthcare division. I'd like to share with you the benefits of Sony's 3D technology for robotic surgery. During this discussion, we will need to take a deeper look into how 3D works so as to give you a better understanding of Sony's 3D products. Sony's 3D offerings include products for visualization, recording, cameras, and our NUCLeUS video routing system over IP. When we discuss 3D for robotics, we are not talking about the types of robots used in the Terminator movies, or the lovable Sony Aibo robotic dog that has 3D visual perception to be able to play games. If you'd like to get one in time for Christmas, they're on sale now. Robots are more prevalent than ever in the healthcare industry. You can find robots in all sorts of the areas within the medical community: rehabilitation areas, pharmacy assistants, mental health, personal well-being, and of course, surgical robotic systems. For this discussion, we'll be talking about high-definition 3D for use in robotic surgery, such as the one we are seeing here, whereby the surgeon controls the robotic arms, all the while viewing the procedure in their very own 3D perspective. Although surgical robots can look a little scary at times, they are a great benefit to surgical procedures, as is our Sony's 3D displays. Robotics have made significant inroads into being able to perform procedures on many areas of the human body. Robotics attempt to improve patient outcomes by making surgery more minimally invasive, reduce blood loss, lower risk of infection, shorter recovery, and improved surgeon health. Multiple companies are vested in creating robotic devices for surgical modalities. Intuitive Surgical has proven to be one of those dominant players in this market for minimally invasive surgery. Let's take a moment and hear from Dr. Scott Magnuson from Florida's Hospital's Nicholson Center.
The vision that we get from the monitors today makes the surgeon feel that I'm immersed in the operation versus looking at something two-dimensionally and recognizing that this is some sort of image produced by a camera. The clarity that we get in the system provides colors that are actually real colors. An example is blood. So in surgery, we have blood that we work with all the time. And when you're operating on a patient in an open field and you're looking at blood, all the colors are true, right? The new monitors today with the 4K and 3D technology, it actually looks like the real field. With a 55-inch monitor and the clarity that we get with this picture, it is magnified, and it's exactly the same as if I was looking through a microscope. Recording today is critically important because before any other time, it was just a verbal communication of how I watched someone do an operation, but as soon as they left, all of those were just memories. It wasn't something they could always go back and refer to. Our surgeons come through the programs, we record their video, we give them a flash drive when they leave so they can review those videos, and we have areas of recommendation for improvement, skill exercises to help them improve so that in the end it improves patient outcome.
Listed here are some of the benefits to having 3D in surgery. Surgical Assist can visualize in the same 3D visual depth perception. Training residents with enhanced visualization offers real-time observation and a better understanding of anatomical structures. 3D has given way to improved surgical techniques and the potential for more efficient procedures. In order to understand the differences in technologies between the 3D glasses, we need to take a deeper dive into how 3D works. 3D content has two separate images, one for each eye. In order to see the 3D effect, we need to ensure that each eye only sees the image that it is intended for, which is why it is necessary to use 3D glasses. To be clear, this is not your grandparents' 3D. Current 3D applications have evolved with the use of polarization of light. There are different formats to consider when displaying 3D. The red and blue, or cyan to be more precise, that you see here is called NUCLeUS, whereby the red lens can only view red images and the cyan can only view blue or green images. There are variations of this that we don't need to go into for this presentation. These images are projected separately to a screen, and the red and blue glasses filter out their respective colors, and your brain can put them back together. The glasses only allow the corresponding light to pass through the colored filter, so your eyes only see what's passed through. Another style is active shutter glasses. Each lens contains a transparent liquid crystal that turns black when the voltage is applied, blocking one eye at a time. These glasses are triggered by an emitter to darken at the right time to correspond with what is projected on the screen. Autostereoscopic is a style of glassless 3D that has a lenticular display and an eye tracking sensor, primarily used in PCs. This 3D requires two views that are projected to only one viewer that can view 3D at a time. If that viewer moves left or right, the 3D image will be lost. The resolution quality of this 3D version has proven not to be very beneficial for medical use. Now we come to 3D polarization. To discuss this, it requires a little bit of explanation of how light waves are perceived. Light has an electromagnetic force which is vertical and horizontal in nature. These light waves create a linear path or linear polarized, as you see here by the red and blue lines. The light wave travels down only one plane of varying amplitude as viewed by the green arrow. If we shift the vertical plane by a 1/4 degree with a polarizer, we then create a circular polarized effect on the resulting light wave. You will now notice the light wave traveling in a circular fashion, represented again by the green arrow, revolving in a counterclockwise motion. To visualize this in another way, polarized images are projected onto a screen, blue represented by vertical light waves and green by horizontal light waves. Linear polarized glasses only allow the corresponding light through the correct polarizing lens. The issue with linear polarizers are that even though you can see what each eye is supposed to see, linear polarized light is traveling in a specific path. If you were to tilt your head, the image would be lost, as the linear light that is traveling that specific path is now blocked by the off-angled glasses. This is where circular polarized glasses come in. Shifting the vertical plane by a 1/4 degree will create circular polarization. Depending on the shift in the vertical plane, you can create a clockwise or counterclockwise polarization. That means for circular polarized glasses, you would have a clockwise polarizer for one eye and a counterclockwise polarizer for the other, as drawn here. The advantage of circular polarization is that even if you were to tilt your head, you would not lose the light coming through the glasses. Sony offers circular polarized visors for advanced protection, lightweight durable frames with removable shields that are replaceable. These shields allow you to visualize 3D comfortably and to view other priorities in the OR without hindrance. The difference between these glasses show the reason passive glasses make the most sense for medical use. Let's now hear from Dr. Mitesh Shah, Professor of Neurological Surgery at the Indiana University School of Medicine.
The best way that a team can be engaged is that they have a richer experience with the flow of the surgical case. So they see the anatomy, they see when there is a challenging part of the case, whether it's the scrub nurse, whether it's your assistant, and they can actually interact because they're looking at the same screen and watching and having the ability to actually help. And all these things are possible by looking at a very large monitor. One of the challenges that I always faced in doing surgeries that were very long, surgeries like acoustic neuromas, was, I had to move the actual microscope thousands of times during the surgery because I wasn't able to see different planes or the depth of the plane I was trying to visualize. In terms of the current model of the digital microscope and the 4K monitor, it's night and day difference in terms of how ergonomic the flow in the OR is. Veins that are still being fed by arteries that are shunting blood are oxygenated. They have a different color. Being able to see that crisper and cleaner with a high resolution monitor is extremely important. I think being able to distinguish what's normal and abnormal or compressed normal tissue is another feature that's very important for a high resolution monitor.
Sony provides two models of 3D displays, a 31-inch version ideal for cart-based or boom arm mounting, and a 55-inch version also ideal for cart-based or wall mounting. There are different variations of the way 3D can be displayed and recorded for later viewing. Depending on the 3D content in glasses will determine the style of 3D created. Sony typically records 3D in a side-by-side format. Here is a sample of side-by-side 3D that was recorded on the Sony 3D digital recorder. The recorder records the left and right camera views that can then create a 2D and 3D simultaneous recording for a surgeon's presentation or training purposes. Sony's digital recorder records high-definition 2D and 3D video. The recorder can record onto its internal hard drive, external hard drive, or onto Sony's NUCLeUS video server, which will be discussed later. Pictured here are some examples of medical robots that utilize 3D technology. Titan Medical, Intuitive Surgical, Transenterics, Synaptive Medical. Let's now take a moment to hear from Dr. Darren Swainston and Dr. Alex Lasani from Nevada's Mountain View Hospital.
One of the advantages of having the Sony 3D monitor in there is we also have the recording unit to record in 3D, not just to visualize in 3D. So we can record that case in 3D, so at a later date we can actually even show groups that are residents or other doctors if we want to train or go to a meeting in a 3D setting.
I think anybody who comes in to view surgery and learn from the technique would immensely benefit from being able to appreciate the same depth perception during surgical manipulation. The assistant is able to see the tissue planes, the area of operation with the same detail as the surgeon does. I think it translates to a more confident assistant, and that in turn translates to a safer operation.
Now that Sony and their 3D monitor is coming on board. It's really adding another layer of helping everyone in the room and those observing. And me, my role now as a teacher, teaching others and helping residents learn, helping other doctors learn how to operate. So to have that collaboration between Intuitive Surgical and Sony is awesome.
As I mentioned earlier, it should be noted that 3D is also prevalent in other specialties besides its uses in robotics. Thank you for taking the time with me, and now I turn it over to Paul Nunez, who will talk to us about the NUCLeUS video routing system. Paul?
Good job, Dave. Excellent work. Not only is Sony a leader in 3D innovations for the clinical space, we're also changing the landscape of video integration. I'd like to introduce you to NUCLeUS. NUCLeUS brings video switching, image capture, video recording, broadcasting, and more to the OR, and without the need for AV techs or any additional support in the sterile space. Many devices brought into the OR today have their own display, which is great, but the problem with a single display is usually only the person standing right in front gets the best view. Think of an ultrasound machine or a surgical robot, for example. Today, hospitals are designing ORs with multiple displays on the wall and on spring arms that rotate 350 degrees around the patient. With multiple displays, everyone gets a great view. So there's the use case for a video integration system. You need to be able to easily send video from multiple sources to one or more displays in the room. We're completely vendor neutral, so any device that generates video can be connected to NUCLeUS. Broadcasting allows us to stream video outside the operating room, which is becoming an important feature as hospitals try to do more with less. We now have the technology that lets one nurse monitor multiple ORs or ICU rooms. NUCLeUS and other video integration systems are an integral part of that solution. One of the most defining features of NUCLeUS is we have the ability to send very high quality video and audio over the existing hospital network using tried and true internet protocol or video over IP. We use the existing hospital network as the transport instead of running point-to-point dedicated video cables from each source to each display. And we leverage the features of most network switches to keep all that network traffic in the OR. So there's no chance that video from OR 1 will end up on a switch somewhere else on the hospital network. As you can imagine, in most cases, this results in much less infrastructure costs for both existing ORs and new construction. You don't need dedicated conduit or a dedicated space to enclose all that AV equipment. And you don't have to design a traditional video switch for a particular set of inputs or outputs. A number of years ago, I worked for a video integration company that made a 16 by 16 video switch, 16 sources and 16 displays. The problem with that is while designing a room, if I had 17 sources and only 2 displays, I couldn't repurpose one of my unused displays as an input. I would need to deploy a second switch at a very high cost, which would mostly go unused. NUCLeUS eliminates that problem. It's just a port on the network switch. It can be an input, it can be an output, or even repurposed entirely if necessary. Here's how it used to be done. You have your alphabet soup of video standards, and most of these are still in use today. All these input plugs, BNC, DVI, DisplayPort, and more would be sprinkled throughout the OR through various ports on walls or booms. The nurse would roll in an ultrasound machine, let's say it has a VGA output, and if she's lucky, there's a VGA input on the wall. Otherwise, she'd have to run a long cable to where the VGA port is, creating a tripping hazard and possibly reducing video quality. Some devices have more than one video output, so a new nurse or a tech that's not familiar with the room can unknowingly connect a low resolution signal to the system, causing poor video quality and complaints from the physician. That video signal would run over conduit to a large AV rack, which was usually in the OR. Imagine the heat and noise generated by multiple video switches, scalers, controllers, video recording equipment, UPSs, and isolation transformers, just to name a few, all in the sterile space. Clearly not an ideal solution, but that's where we were just a few years ago. We have a better approach. NUCLeUS uses an IPC or an IP converter to normalize the entire alphabet soup of signals into one uniform signal. As you can see, the inputs are all the video standards in use today, and the output is an RJ45 network jack. During the installation process, we attach one IPC to every source, whether it's a fixed source like a computer or surgical light camera, or a mobile source that you would wheel into the room, like an endoscopy tower or surgical robot. And then we attach one IPC on every display. That's the extent of the hardware footprint in the OR. No video rack, no additional fans, no dust collectors. And since the video connection between the device and the IPC has already been made, the user simply locates a Sony network port and plugs it in. That source is now available for recording, switching, or broadcasting. We support virtually any modality: standard definition, high definition, 2K, 4K, 3D, radiology imaging, surgical light cameras, PTZ cameras, glide scopes, microscopes, surgical robots, whether 2D or 3D. No additional hardware required. If it generates video, we can connect it to NUCLeUS. I mocked up this simplified view of an OR using a surgical robot, showing the connection points to NUCLeUS. I'm not trying to pick on Intuitive here. It was just easier to find their content online, so I used those photos. NUCLeUS supports all three surgical modalities. So you have your physician's console there on the left, connected to NUCLeUS IPCs, which are shown much larger in scale so that you can see them easily. In reality, those IPCs are about the size of a small cigar box. We have a 2D and a 3D wall display. Each display will have its own IPC connected to the network. And there on the right, we have our 21-inch touch panel, our user interface, which allows a nurse or tech to easily control what content is shown on the displays. And the reason we have two IPCs at the console is so that we can feed the patient vital signs back into the console. Integrating with NUCLeUS is easy, and it's just one example of how NUCLeUS ties into a 3D surgical modality. The NUCLeUS IPC can generate multiple streams simultaneously: a high-resolution, low-latency native stream that connects directly to the IPC on the display, and also an HD proxy stream that's used for video capture, image capture, and broadcast functions. For 3D formats, we support top and bottom, as well as line-by-line 3D. We can record multiple sources with various resolutions at the same time. And we can capture images from various sources at the same time and broadcast multiple sources to different locations within and outside the hospital. The flexibility of this system is virtually unlimited, and our existing customers are already coming up with new ways to use NUCLeUS. Our user interface shown here is designed to be easy to use and can be accessed with a 21-inch touch panel like you see here, or via any local computer connected to the hospital network using a browser. Only those sources that are connected in the room are shown. So in this case, we have three sources. We have a PACS computer, an in-light camera, and patient monitoring, and we have three displays. Just touch where the source and the in-display intersect, and that source video is automatically switched to that display. In this case, the in-light camera is routed to display 1 and 2, and the PACS is routed to display 3. You can also easily create tiling arrangements that can show multiple images on one display. Picture in picture, picture outside picture, quad, and so forth. I won't get into all the features here, but we support EMR integration, which allows the patient list to be shown on the touch panel for easy registering. We can automatically or manually upload content to PACS or to the EMR via standard HL7 messaging protocols. NUCLeUS supports rough editing, bookmarking, telestration, and more, and allows you to quickly capture key moments during your case to be located easily after the case. Initiating a broadcast is as easy as touching the source and then touching the broadcast icon. Once the broadcast is underway, any user with the right credentials can log into NUCLeUS and view the broadcast. NUCLeUS supports simultaneous broadcasting of 2D and 3D live content. So not only can everyone see 3D in the OR, anyone watching the broadcast outside the OR can get that same great immersive experience. We focused on tying 3D modalities with NUCLeUS in this webinar, but NUCLeUS can do a lot more. Once it's installed on your network, it seamlessly integrates with all clinical and non-clinical spaces, conference rooms, other ORs, pathology, wet labs, simulation rooms, doctor's offices, etc. With System Watch, we monitor all major elements of the system 24/7 and will alert your clinical engineering or IT department at the first signs of any problem. Not only is integrating 3D modalities possible, with NUCLeUS, we make it easy. If you're a healthcare provider and you don't have the room or budget for a large infrastructure project, but you need this functionality, reach out to us and we'll be happy to provide a personalized demo or set up a proof of concept to see if NUCLeUS is right for you. Thank you for spending your time with us, and we look forward to seeing you again. Don't forget to follow us on social media. And now we'd be happy to answer any questions that you have about 3D for robotics or NUCLeUS. Thank you again.
Dave, maybe you can talk a little bit about your experience in setting up a 3D in an OR.
Sure. Depending on the system, they have different video outputs, and knowing which is available, we typically grab the left and right camera image, and that can either go directly straight into a display. Our monitors have the ability, I showed in my presentation, there's different formatting for 3D, side by side, top, bottom, left, right, over, under. A lot of people do it differently. There's no real standard to say, but our monitors and our recorders can capture anything that's being put out. And like I say, for our displays, we can go direct into that to give you 3D. Our digital recorder can capture that video signal left and right, and simultaneously grab either the left or the right view to give you a 2D recording as well as a 3D recording. And then going into our NUCLeUS system, we can capture that as well. And we also, what I didn't mention is we have the ability for 4K 3D when that becomes available. We're already there to be able to capture that.
Great.
And Dave, what about the field of view? So when you put the 3D glasses on, how far off to the side can I be and still get a great 3D image?
Our monitors have a wide field of view, 170 degrees, so you can be off angle on that on the monitor to be able to view left or right as I'm moving here. But it is a more focused top and bottom, so you want to have that monitor angled towards you, but you have a wide field of view to be within that space to view it. If you are going above or below a certain line there, you'll start to lose the 3D. It'll start to shift over into a 2D platform. So it is critical that you aim the display and angle that to whether you're sitting on a stool next to the patient table, or if you're standing to the side and have another display, you want to make sure that that's pointing at you.
Very well, yeah. And I think one of our attendees asked the question, how easy is it to record from the robot? So remember, one of my slides had the user interface, and it's simply a one button press on the user interface to initiate recording. So you push once for recording, a little timer starts, and then you push again at the end of the recording. It's basically one touch recording at that point.
Another question from the audience is, does it allow for telestration? So yes, telestration is one of the licenses we have. So you're allowed to telestrate between yourself and anyone else on the network. You can have multiple users, talking and discussing at one time. The idea is you'd have maybe a second opinion where the doctor in the OR is talking to another physician on the network, or maybe you have another chief of staff looking in on a doctor who's in the room. Many different use cases for it, but yes, telestration it is one of the available options in the NUCLeUS system. Another question, with NUCLeUS, video storage is an issue. What can be solved? Hold on, let me see, it's cut off. Yeah, kind of a half an answer, half of a question. So video storage can be an issue when you're storing 3D and 2D simultaneously because you're getting twice the recording ability. Our systems are recording at about 25 megabits per second, which equates to about 10 gig of storage per hour. And as long as we understand initially what the setup is and what the expectations, how many hours a day are you recording, how many ORs, how long do you keep it online? With that, we can calculate a very good estimate of how much storage space is required. Typically, when you're having a regular, maybe a 4 OR solution, it can be somewhere in the terabyte range. Some hospitals want to keep it for 3 months and then cycle the storage. Other situations is they want to keep it for much longer, and we have to make sure we confer with the IT group within the hospital to make sure that they've allotted the correct amount of storage for that.
And we also have the ability to archive recording, which will allow you to record a source or multiple sources in archive quality bit rates, which are a lot less than recording in full quality, and therefore will extend the life of your storage and the capacity of your storage by recording in archive quality. So you have that ability as well.
Another question, is this something that has to be an institutional buy-in, or could training and teaching labs buy it themselves? Of course, we work from anywhere from 1 OR up to multiple ORs. So if it was just a training and teaching lab, they can certainly get this. We can size the solution for the needs because this is mostly software-based. Really, all we need is a couple of servers to do the calculations for that. And when we have our initial consultation with the customers, we kind of figure out what size is required, how much storage capacity, how much computing power, and we can size it appropriately for that specific customer. Any other questions?
Somebody asked, can you record all sources simultaneously or multiple sources? And the answer is yes. Some of the other video integration companies on the market limit you to recording either only one source or a couple of sources. With NUCLeUS, you can record everything in the OR at the same time. It's limited only by the speed of your network back to the storage, and it's just hitting a button on every source to initiate the recording. So the answer is yes.
Yeah, just to add on to that, it's very flexible in that respect, in that when you typically buy a storage device, it's limited to 1 or 2 inputs, but with NUCLeUS, you're not limited to that. Every single input that's put in can be recorded. In some cases, we've done 8 recordings at a time, especially in hybrid labs, things like that. You might have multiple inputs that you want to record. So it's very interesting to work in those type of parameters where you don't have the limitation of a piece of hardware that says you can only record 1 or 2 inputs. Is the data stored locally within the institutional firewall, or do they go outside the institution for storage? Currently, it really depends on the IT people. The IT would give us a URL or a CIFS connection that allows our system to do storage. We just point to that storage, they really maintain the storage. We do for smaller institutions come up with our own on-premise storage, but typically IT is storing on the prem with storage area network, and occasionally we do run into them where they're pushing it up to the cloud. So our system is agnostic when it comes to that. We just need a place to point to, and as long as that's given to us by IT, we can push it anywhere.
Then there was, this is more of a comment than a question. There was a comment about, the concept of 3D visualization for the surgical assistants that are, helping with in a robot case. And, is there a value for everybody in the room to see in 3D? The benefit seems obvious. So I agree with that comment. There is, I've been in rooms where, we've handed surgical techs and the assistants 3D glasses, and the benefits are very obvious. They can see exactly what the doctor's seeing, and they get a much more immersive experience. And with the glasses, they're very light. You can keep them on for hours, and it's very easy to just move away and see something else in the OR besides the 3D screen and still be able to see what you're doing, even when you're not looking at the 3D screen. So yeah, I believe there are obvious benefits to having everybody in the room see in 3D. Thank you for that question.
I can even add to that also, Paul, as I've witnessed and been in there, where they are able to see in that same 3D perception and be able to grab a bigger bite of tissue that's necessary, or to be able to cut in the location that the surgeon wants. And I've even had a surgical assist come up and say, thank you for this. The doctor is not yelling at me anymore because I didn't grab what he needed to grab in the right place or that. So it is beneficial for them to see in the same 3D platform.
Absolutely. Yeah, good point, David.
So another question, I'm going to direct this to David, David Alexander. When is this coming to the market? Can we check out pricing somewhere on the web?
So general pricing is created on a per project basis, as you could imagine. The configuration capabilities and possibilities are very deep with NUCLeUS. Everything from remote patient monitoring to record-only systems to ORs to hybrid rooms to robotic suites, all kind of within its scope of work. There is some published list price of some of the parts, but generally it's all custom configured. So it's not just right online. When you get in touch with your local Sony representative, they'll go through the process with you to make sure you get completely accurate pricing. If you're a consultant and or architect, we'll follow up with you as well to make sure you have the ability to create a budget for a project and understand the amount of expense we're looking at in these systems and various configurations.
So the other part of that question is, when is this coming to the market? It actually received FDA marketing approval earlier this year. It's been on the market since the beginning of 2020. We continually are making improvements. About every 3 to 6 months, we come out with feature updates where we're adding new features to the capabilities of the system based on feedback from our customers. Another question, with NUCLeUS, can each surgeon have their own file to be accessed later for editing or viewing? Dave K., do you want to answer that on CMS?
Yeah, so when you record within the operating room and you set up for the patient file, you put in certain patient criteria, some metadata information, and including that would be the surgeon who's performing the surgery. And once you hit record, based on that metadata information, it's going to open up a file within the CMS system or buried within NUCLeUS that the surgeon will have their own location. The surgeon then, after following the procedure, would be able to find that file and be able to edit that file or share that file. If there is a collaboration, they do have the ability to allow others to create a community for that file to have discussions or presentations.
Excellent.
So another question, can you start out with just the 3D displays and then grow your system? So yes, 3D displays allows everyone in the room to see it. If you have a teaching opportunity, you can add recorders which are locally based. They would record in 3D and allow you to either send to NUCLeUS later on, or if you just had the immediate need without having to store it on an IT-based system, you can walk out of the procedure on a USB stick that would be your recording. So you can take the modular approach, start with 3D viewing, then work to recording, and then finally work up to recording and archiving on the NUCLeUS system. Another question for David Alexander. Is Sony seeing a growing trend with robotic facilities looking for a full integration solution like Sony NUCLeUS?
Yeah, believe it or not, it's not the most, logical thing when you think of a robotic suite that has primarily one source as needing, an ability to switch video or record. However, recording obviously always a challenge in 3D and 4K. NUCLeUS facilitates that. Sending imaging to other secondary monitors seems to be a primary use for NUCLeUS in robotics. I've designed in the past suites where there's a central room for residents and others to view the procedures so they can gather around a large screen display, for example, typically in 3D, and view the procedure without being in the room, without being in the OR. And usually that's right outside so they can still be in touch with what's going on in kind of the control area compared to the room, or compared to the information from the nurses that's coming in and out of the room. But it's a great way to, especially in the academic environment, to get the residents away from the primary surgeon during a case, but still be directly involved in learning and watching high quality 3D video. So it's used for that quite a bit. And yes, we do see a trend in that direction. The need for switching and routing is there too. If you are recording and or communicating to a classroom or a lecture hall, there's always things needed like confidence monitors so you can see what signal's going out, potentially monitoring of vitals and other things. Should you ever need a scope to be used on the fly, you can roll one in and record that, view that, switch that as well. So it's extremely functional in a robotics suite for many different purposes.
Good point. One thing I'd like to add is with NUCLeUS, you could have a room, you could easily repurpose a room to be a surgical robot room, and without losing any functionality. You can, one example, one of the facilities where we have NUCLeUS installed, they've turned one of the rooms that was traditionally used for robot surgery into a COVID room, and that prompted the need for them to move that robot into another OR, and they were able to easily do that without really losing any functionality at all as far as recording and streaming and conferencing. So there's lots of benefits.
In the past, undertaking any reconfiguration like that on the fly involving baseband cabling to be put in, vast amounts of electrical work, NUCLeUS lets it happen on the fly with just data connection. Huge benefit.
Good questions. Great questions, actually. Thank you.
Yep. Anybody else have questions?
Going once?
Just one final. We had a question I saw before. Maybe it got squashed down. Is there any ability to use NUCLeUS with other systems directly via API?
Yeah, so NUCLeUS has a very robust API for those who are willing to do a little bit more development. So our user interface is based on our own internal API, which is an application programming interface. So for instance, if there was a manufacturer out there who wanted their own look and feel, we give them all the tools to make those changes so that their user interface is exactly the same across their products, rather than using a Sony product look and feel. The API allows you to develop it on your own with the help of us, of course.
And there was one last one in here. How frequent is the system serviced and maintained?
So with the system, one of the things that we sell along with it is our remote monitoring service, our RMS. What this does is it's an agent that runs on our computers, and it continuously monitors the system, both hardware and software, for any anomalies. The idea being we could be alerted of a system problem or issue that's arising before it's actually seen by the customer. So this would send an alert via email to our network operations center, which is manned 19 hours a day, basically from 6 a.m. to 2 a.m. East Coast time. And within minutes, we'll respond and try and intervene, troubleshoot, and fix the problem before it actually manifests itself to the customer. It's just one of the added benefits of having an IP-based system, in that we really probably do not need to come on site to make the repairs. We try and do everything remotely through software. David, no more questions. Did you want to wrap it up?
No, that was it. Do submit any last minute questions that occur to you. You have a minute or two to do that. Again, we will follow up with you directly to make sure you get the information, since we couldn't get to it here. Don't be afraid of heady engineering questions as well. But for pricing and, again, more information, be in touch with your Sony healthcare representative, your Sony other representatives, should you have any for any other product lines that you deal with, can get you in touch as well. But otherwise, that's it. Wish everyone to stay happy and healthy, stay safe, happy holidays. Thanks for your time today.
Thank you.
Thanks, everybody.
Thanks, everybody.